Sorry for the long-windedness. But yeah, so for example, we could say, that every Thanksgiving, right? Grandma makes potato salad will imply bathroom gets wrecked. I love a grandma's potato salad, but can we see the whole thing? We can't see the whole thing. Yeah, maybe smaller. Implies bathroom gets wrecked, right? So this is a conditional statement. And we already know it's going to be the same as the contrapositive. So every Thanksgiving, if the bathroom doesn't get wrecked, that means grandma must have not made her potato salad, right? That's fine. But actually, first of all, let's write this. Let's write this in mathematical notation, right? So I'll call this. So what's our variable here? What's our variable going to represent? It's kind of a good question, right? Like, we know it's a universal statement because we're saying every, but for all what in what? We have
Thanksgivings in possible Thanksgivings, maybe?
Yeah, everything's even possible Thanksgiving. What I'll say is let y equal years, right? And then so we're gonna let y equal years, and then we're gonna have p of y is gma makes salad on year y, and then q of y is gonna be bathroom is wrecked on year y. Make sense? Then the statement is saying for all years in y, if grandma makes potato salad on year y Thanksgiving, right? Bathroom is wrecked on year y Thanksgiving, right? For all y, p of y implies q of y, right? That's all this statement is saying here. And so the contrapositive is totally equivalent, right? Like assuming this statement is true, the contrapositive would totally be true. Every Thanksgiving, the bathroom doesn't get wrecked, grandma must have not made her potato salad. That's totally true. But is the converse true? So how about what about for all y and y, q of y implies p of y? Can we say that's true? For every Thanksgiving, if the bathroom gets wrecked, does that mean grandma made potato salad?
Nope.
No, because there's more than one way the bathroom can get wrecked, right? We don't have to go through the ways, but the thing is, there could be other disgusting dishes disgusting but delicious dishes at Thanksgiving. So the point is, yeah. So just for the exact same reasons, why the inverse and the converse aren't always equivalent to the conditional, we have the same thing here. They're not always going to be equivalent. And here it even makes more sense because once again, right? When we're talking about these universal conditionals, they relate to properties. So the property of a Thanksgiving having potato salad implies the property that the Thanksgiving of the bathroom get wrecked, right? And so it's not a coincidence that on one Thanksgiving, grandma made potato salad and the bathroom got wrecked. We're saying every time it happens, every time grandma makes potato salad, the bathroom gets wrecked. And then we're saying, but then the converse of that kind of points out that, okay, well, maybe coincidence the converse points out that not every time the bathroom gets wrecked, grandma makes potato salad. There could be a coincidence. Anyway, so what that showed is sometimes P of x implies Q of x is not equivalent to Q of x implies P of x, right? Sometimes they give different truth values. Have different truth values. But let's consider another example. Let's consider the example, but is this always true? Will they always give different truth values? What do you guys think? This was basically a question on your written assignment 3 homework, right?
Didn't you? Oh, sorry.
What are you saying?
Oh, I was saying, wasn't it something about when one is kind of like the definition of the other? They pretty much always are equal.
Yeah, you can have biconditionals. So this is the big point. It's some people miss this on the homework. If ask me about the two domain thing after class is a good question. But definitely want to talk about it. But we want to get through this first. So yeah, you got right. Biconditionals totally exist, right? Saying they're not equivalent, right? Saying two things are equivalent means that they will always give the same truth values, right? For whatever case you have, pick a domain, pick some predicates, they'll always give the same truth values, right? But being unequivalent, right? If two general statements are unequivalent, that just means they won't always give the same truth values, but sometimes they will. They're just different statements. P of x implies Q of x, and Q of x implies P of x are just two totally different statements. They're saying different things. They happen to have some of the same letters, but they're different. Or two different things could sometimes give the same truth value, right? Two different things can be true at once. That doesn't mean they were equivalent, doesn't mean they came from each other, it just means we had a coincidence, right? So, for example, for all n and z, if n squared minus 4 equals 0, then n equals 2 or minus 2. All right? Is this true or false? Dutch angle. There we go. For all n and z, if n squared minus 4 equals 0, then n equals 2 or minus 2. Well, it might help, right, that we can write this as n minus 2 times n plus 2, right? You guys remember that factoring? Difference of squares?
Yeah, it's true.
Yeah. Exactly. It's true, right? This is a true statement, right? Because when we factor it like this, we see, okay, well, n squared minus 4 equals 0. That means n minus 2 times n plus 2 equals 0, right? So in order for that to happen, n's got to be 2 or n's got to be minus 2, right? if n was anything else, right, we wouldn't get 0 here, right, and we wouldn't get 0 here. Like if we had 3, we get 1 here and 5 here. If n is anything but 2 or minus 2, if you plug it into these two things, you get two non-zero things, and two non-zero things multiplied by each other aren't 0, so it wouldn't be true. So in order for this to be true, n's got to be 2 or minus 2. So that's true. How about this statement? True or false?
True.
True. Because it happens to go both ways. So sometimes it goes both ways. Sometimes P of X will imply Q of X, like here's your P, here's your Q. Right? Sometimes P of X will imply Q of X, and Q of X will imply P of X. Sometimes it goes both ways. But that's just a coincidence. It doesn't have to. I mean, I like this. I'm not saying this is a coincidence. This is a deep mathematical fact. What I'm saying is that just knowing P of X implies Q of X, you don't know Q of X implies P of X. But you don't know it's false either. If you know P of X implies Q of X is true, sometimes this will be true, sometimes it's false. The point is you just don't know. They're different, right? They're not opposites, they're just different. Any questions on that?